Welcome to our module on deployment and DevOps specifically for MERN stack applications. Here, we will learn how to reliably automate and host your MERN applications effectively. We will now explore some key CI/CD concepts to build a strong foundation. Specifically, we will dive into continuous integration, continuous delivery, and continuous deployment in detail. Let's start by understanding continuous integration, often abbreviated as CI, which is crucial for modern development. CI automates the process of integrating code changes from multiple developers into a shared repository frequently. This practice ensures that code merges smoothly, preventing integration issues and maintaining a consistent code base. Next, we have continuous delivery or CD, which builds upon continuous integration practices. Continuous delivery ensures that your application's code is always in a deployable state and ready for release. This means the software can be released to any environment, like staging or production, whenever needed. Finally, let's look at continuous deployment, which takes continuous delivery a step further. With continuous deployment, thoroughly tested code is automatically released to the production environment without manual intervention. This complete automation streamlines the release process, significantly reducing the need for manual steps and potential errors. So, why should we use CI/CD in our software development workflow? Let us see. It offers significant benefits for making your software development more efficient and robust. First, CI/CD helps speed up your deployment process significantly. It automates builds and tests, allowing for much faster and more consistent software releases. Next, using CI/CD helps to significantly reduce errors in your code. Automated checks detect bugs early in the development cycle, improving overall code quality. Furthermore, CI/CD is excellent for improving team collaboration. Developers can integrate their code frequently and smoothly, fostering better teamwork and coordination. Finally, CI/CD is essential for enhancing the scalability of your applications. It enables rapid and reliable software releases, supporting growth and increasing user demands. Let us now look at a typical CI/CD workflow, specifically tailored for a MERN stack application. We will cover the standard steps involved in automated application delivery from code to production. The workflow begins with a code commit from developers. Developers push their code changes to a version control system like GitHub, GitLab, or Bitbucket. Next, the build process starts automatically. Here, your code is built using tools like Webpack, Babel, or Node.js for compilation. Following the build, automated testing is performed. This involves running unit tests, integration tests, and other automated checks to ensure quality. After testing, a code review takes place. Pull requests are thoroughly reviewed by team members before merging the code into the main branch. Then, the code is deployed to a staging environment. This test environment allows for final verification before the application goes live to users. Finally, upon successful staging, the code is deployed to production. This means the application is now live and accessible to all end users on the server. Now, we will define a CI/CD workflow using GitHub Actions in a file named ci-cd.yml. This automates the build and test processes, ensuring a continuous integration pipeline. We start by defining the workflow and its triggers. This workflow, called CI/CD pipeline, triggers on push or pull request events to the main branch, automating integration. This code block shows the workflow named CI/CD pipeline, triggered by push or pull request to main. Next, we configure the build job, which is a key part of our CI/CD pipeline. The build job runs on Ubuntu latest, setting up Node.js, installing dependencies, then running tests and building the project. This code outlines the build job, including checking out the repository, setting up Node.js, installing, testing, and building. Now, let us define the deployment stage within our ci-cd.yml file. This automates the production deployment after the successful completion of all builds and tests. Here, we define the deploy job. This deploy job runs automatically on Ubuntu latest after the build job successfully completes, deploying to production. This code snippet shows the deploy job which runs on Ubuntu latest and depends on the build job. We will now implement the deployment using an SSH action, securely connecting to our server. This action uses secrets for host, username, and SSH key to connect, pull latest code, install dependencies, and restart with PM2. This code block details the deployment steps, including using SSH action with secrets to pull code and restart the server. Let us explore some common hosting platforms suitable for deploying your MERN stack applications. Choosing the right platform is crucial for the performance and scalability of your MERN application. First, we have Heroku, a popular choice. Heroku is known for being easy to use and beginner-friendly. It also offers a convenient free tier, which is great for small projects and learning. Next, consider Vercel, especially for your front end. Vercel is best optimized for hosting front-end applications, particularly React apps. It provides seamless deployment for your client-side code. Then, there is AWS, Amazon Web Services. AWS is highly scalable and ideal for enterprise-level applications requiring robust infrastructure. Key AWS services for MERN include EC2, S3, and RDS. Today, we will introduce version control using Git and GitHub, essential tools for developers. These tools help you track changes and collaborate effectively on software projects with your team. One primary function of Git is tracking changes. It allows you to view all modifications made to your code over time. Git maintains a detailed history of all code versions, so you never lose any work. Git also facilitates collaborative development among multiple team members. It enables multiple developers to work on the same project simultaneously without conflicts. Git manages concurrent code contributions seamlessly, making teamwork efficient and smooth. Another crucial feature is branching and merging. You can work on new features or bug fixes separately using branches. Then, integrate these changes without affecting the main project until they are ready. Finally, Git provides excellent backup and recovery capabilities. It prevents accidental code loss by saving every change you make securely. You can easily restore previous versions of your code if something goes wrong. Let us now go through essential Git commands that you will frequently use in your MERN projects. These are key commands for effective version control and seamless team collaboration. To start a new Git repository in your project directory, you will initialize it. Use the command git init to create an empty Git repository. To prepare files for your next commit, you need to add them to staging. The command git add.stages all changes in your current directory. To save your stage changes with a descriptive message, you will commit them. Use git commit -m followed by your message. For example, initial commit. To link your local repository to a remote repository on GitHub, you connect it. The command git remote add origin followed by the repository URL sets up the connection. To upload your local commits to the remote GitHub repository, you push them. Use git push -u origin main to send your changes to the main branch. To work on a new feature without affecting the main code base, create a new branch. The command git checkout -b. Feature -branch creates and switches to a new branch. After completing a feature, you will merge its changes back into your main branch. First, switch to the main branch. Then use git merge feature -branch to integrate changes. To get the latest code updates from your GitHub repository, you will pull them. The command git pull origin main fetches and merges the latest changes into your local branch. In this section, we will discuss managing environment variables in your MERN stack applications. This is crucial for securing and configuring sensitive application settings across different environments. Let us begin with an introduction to what environment variables are and why they are important. Environment variables store configurations like API keys and database credentials, enhancing security and offering flexibility across environments. To enable environment variables in Node.js, first install the .nb package. Next, we will see how to load these variables effectively within your Node.js backend. The .nb package loads variables from a .nb file into process.nb. Use them for database, URI, or secret keys. This code loads environment variables, sets the port, and connects to MongoDB using process.nv.mongo URI. Now, let us look at how to use environment variables specifically within your React frontend. For React, Create a .env file in your project root, prefixing variables with react_app_ for client-side exposure. This code snippet shows an example .env file for React, defining the react_app_API URL. Finally, we will cover how to access these environment variables within your React components. Access variables in React components using process.env. React_app_var name. Connecting front-end services dynamically. This code shows accessing the API URL from process.env.react_app_API_URL to fetch data. Let us now summarize the key concepts covered in this module on deployment and DevOps. Here are the main takeaways to remember from our discussion on MERN stack deployment. CI/CD automates code integration, testing, and deployment, ensuring efficient software delivery. GitHub Actions streamline CI/CD workflows, making automation straightforward for MERN applications. Heroku, Vercel, and AWS provide diverse hosting solutions tailored for various MERN app requirements. Environment variables are essential for securely storing sensitive configuration data, promoting security and flexibility. Git and GitHub are fundamental tools for version control and effective team collaboration on projects.